Welcome to this video on correlation. By the end of this video, you should be able to interpret the correlation, understand the basic properties of correlation, including how the correlation is influenced by unusual points, and distinguish correlation from causation. Okay, so we're going to complete this How Safe is Barbie activity. Make sure you have a calculator. I'm going to show you how to use the calculator to do this work, and if you don't, you can go to staplet.com. in order to input the data there. So how can we be sure that the bungee cord we make Barbie will keep her safe? Should you be worried if you use the wrong units, chose the wrong axes, or measured wrong? So we did Ziploc water bags, but the rest of the lesson is going to be about Barbie. So here is some data. What I would like you to do is make a scatter plot here. I don't think you need to go to Staplet for this. You can make a scatter plot here. You should have that skill set. Alright, so here I have sketched in our scatter plot. Everybody should have the same thing down here because there was 0 to 7 rubber bands. Make sure it's labeled rubber bands. The distance traveled, this was measured in inches. So make sure we say inches right there. And the title of the graph, the scatter plot, is rubber bands versus distance. You should have a fairly linear looking graph here. Now, to find the correlation, I'm going to show you how to do this in your calculator. So you are going to go into Stat. So let's see here. Let me clear out my calculator. Okay, go to the Stat button, and we're going to edit our lists. So we want to go into List 1 and List 2. The number of rubber bands we're going to put into List 1, and the distance traveled we're going to put into List 2. Okay, so in List 1, remember you hit Enter after each one. So 0, Enter, 1, 2, 3, 4, 5, 6, 7. So we have all our rubber band options. Now we're going to put our distance traveled in. You want to make sure they line up. 0 has to have 12 next to it because they go together. So pause the video if you're still trying to get your data in, but we're going to move forward. Now, to find the correlation coefficient, we're going to talk more about what this is. It's really the strength of a relationship, and it always uses the variable R. Okay, so you want to hit the Stat button, arrow one time over to Calculate, and you want to go all the way down to where this is ln reg a plus bx. There's one earlier, that's ax plus b. We do not want to use that one. We want to use number 8. So you can just hit the number 8 and it will take you straight to it. Now our data we put into List 1, List 2. So I have List 1 for my x's, but notice that does not say List 2 for the y's. That's okay, that's an easy fix. List 2, if you look above the 2, you'll see L2 in the blue. So that means hit the blue button and then the number 2. And that will change it to List 2. So we put our data in List 1, List 2. Don't put anything into the frequency list. Just keep entering, get to Calculate, and hit Enter. Now, if you do not have all of the information that you see on my screen right now, you need to do a quick thing. You should only have to do it this once. Down here in Catalog, see how it's in blue, so we're going to hit the second button and the word Catalog, and it brings up this whole list. You're going to keep going down, scroll down until you find Diagnostics On. So it's in alphabetical order. So we're just going to keep going. Okay, so there's a Diagnostics Off and a Diagnostics On. Diagnostic Off you'll probably only have an A equals and a B equals there. You don't want that. You want to hit Diagnostics On, you'll hit Enter, and enter again. So now it says it's done. So then we'll go stat calc. We chose number 8 before. Everything's in list 1 and list 2. And you should have all 4 of these. The only thing we're worried about right now is R. R is the correlation coefficient. And we'll use 4 decimal places because R, the correlation only runs between -1 and +1. So you want to use a few more decimals here to show some differentiation that can come up. 3 or 4. We can go with 3 this time. I think we'll be okay. So 0.992. So my correlation coefficient is 0.992. Well, the very strongest it could be is a 1. Okay, that's pretty close to 1. So how safe do you feel Barbie's bungee jump would be if we were to use this data and use the correlation to justify? Well, I would feel pretty safe. In fact, I think I'd even say very safe, because that is a pretty strong correlation. So, what I want you to do at this point is pause the video, and I want you to try 4, 5, and 6 on your own. So, each of these have you doing something, adding in a point. So, add in the point, but when you go to the next one, take out this point and add in this new point that they're talking about. So, when you go to do number 6, take out this point and add in the new point that they're talking about. Tell them to do what they're doing down here. And so each time you're pretending you're starting over from the beginning. When you're done, come back and watch the rest of the video. Alright, well, let's see how you did. When you added in 15 rubber bands and 49 inches into the scatter plot, I got a new R value of 0.998. So 0.998 is more than 0.992. So it actually strengthened the correlation. So let's write that down. Okay, so the new point made the correlation stronger. Okay, now you should have deleted the 15 and 49 and added in 6 and 6 for this point. What happens to the correlation on this one is I got a correlation of 0.8377, so maybe 0.838. Well, this is less than 0.992. So the new point weakened the correlation. Alright, so your new point weakened the correlation, and if you ran it the way you were, I actually told you to, I believe 0.499 you would have probably gotten for your correlation. So it weakened the correlation. So let's kind of look at these up here. I added the points to our graph. This was the 6, 6. This weakened the correlation. And this was the 1549, and it strengthened the correlation. I wonder why that is. So we will formalize that in just a minute. Alright, so for your very last, they took all the information and they multiplied by 2.54 on your distance traveled to convert it from inches to centimeters. When you calculate this, I got a correlation coefficient 0.992. Well, isn't that what we got right up here? Even though we used the inches traveled instead of centimeters traveled, I ended up with the same correlation. So the correlation did not change. So let's talk about a few of these things here. So when we have our graph, make sure you've got your title. Make sure you've labeled your axes. Okay. When we want to talk about our correlation, I want you to interpret correlation as strong, moderate, or weak. So this one, this is almost to 1. So we're going to say, we're going to interpret it as strong. This line has a positive slope, so we'll say positive. And the shape that it makes is linear. Strong, positive, linear pattern. That's how you're going to interpret. Okay? So, we were talking about adding points here. We added this point out here at 1549. And when you recalculated, your correlation increased. So if you have an outlier that falls in the pattern, it will strengthen your correlation. So for correlation, I'm just going to write R. So I've got this pattern going, and if I kept going and made my graph bigger, this falls in line of where the pattern would have gone. That's going to strengthen your correlation. However, when I added this point, my correlation went down. So when you have an outlier outside of a pattern, it will weaken your correlation. Okay, so if you're outside the pattern, that weakens your correlation. In line with pattern, and it will strengthen your correlation. Okay, that's an R. Okay. So you've learned about interpreting. What happens if you have an outlier depends on where the outlier is. Then in this last question, we changed the units. We went from inches to centimeters and nothing changed. Because changing units will not change R. Changing units does not change R. Alright, let's summarize these notes on the back. Okay, so I have 3 things I need to tell you here. This last one does not require too much room. And the first one requires just a little bit more room. That should give us some good... So to interpret R, so if I say interpret this correlation coefficient, you're going to tell me direction as either positive or negative. Your form for correlation is always linear. You can't find a correlation coefficient, you can't use a correlation coefficient, let me put it that way, on a non-linear shape. So it should always be linear. And your strength, so your correlation goes from -1 to +1. That's its entire range. Okay, so your -1 would be considered a strong negative. So the negative just tells you it has a negative slope. The positive tells you it has a positive slope for the line. So your positive one then is going to be strong. 0.5, this is more of a moderate on both sides, or moderate. And 0 is there's really none. I'm going to give you a range here that I usually use to help when I'm trying to decide what words to use. So if you have a plus or minus 0.7 to 1, go ahead and call that a strong. That'd be a strong correlation. Then positive or minus 0.5 to 0.69, we'll call that moderate. Positive or negative 0.2 to 0.49, we'll call weak. And then everything else would just be no correlation. So if you're lower than 0.19, positive or minus 0.19, no correlation. Okay? So there's some properties that I want you to know that are true for your correlation. Alright, so your correlation properties. Your correlation R does not have units. So you wouldn't say the correlation is 0.98 inches. There's no units on correlation. It's just the number. Okay? What if you messed up and you assigned the wrong response and explanatory variables? Well, it's not going to affect your R. Okay? So if you switch their axes, it's not going to affect the R. The other is that your correlation is non-resistant. Remember, we talked about resistance and non-resistance with the median and the mean and standard deviation and IQR. If you have an outlier that's in your pattern, that's going to strengthen your correlation. But if you have an outlier that's outside your pattern, it's going to weaken your correlation. And the last thing you need to take away from this is correlation does not equal causation. Just because they correlate does not mean that one causes the other to happen. It just means they have some sort of relationship. Okay? So what I want you to do is pause the video, try to check your understanding on your own, and come back and check your answers. Alright, so let's take a look. So they gave you the correlation coefficient, and I described it. That's it's a moderately strong. It's not as strong as like 0.9. So I went ahead and just said moderately. There's one of those LY words where we kind of get a little fudgy. Moderately strong, positive linear relationship, and then go on to say the context between chocolate consumption and Nobel laureates. Okay. So if the people in the United States started eating more chocolate, can we expect more Nobel laureates to be awarded to the residents of the United States? No, we can't. Correlation does not mean one variable causes change in the other variable. That's important. Just because a change in one doesn't mean there's going to be a change in the other. There is likely something else that was impacting both variables. That's your correlation does not equal causation. Okay? So what effect does Switzerland have on the correlation? So here is Switzerland, right there. And if we kind of look at all the points, and you wanted to draw a line in there, it's hard because they get a little spread out. But Switzerland kind of follows the pattern. So Switzerland strengthens the correlation because it follows the linear pattern. Alright, so hopefully that worked out pretty well for you. We're going to have a really short quiz on Wednesday over the concepts from the first 2 days. Take a look in your book too to help with some questions you may have. Email me and let me know if I can answer anything. See you in class.